everyone, to this week's episode of Tech Talk. We're going to be having a special interview. With us today, we have Elad Harison, who is the COO of IAGON. Did I say that right?
That's right. Well, we pronounce it IAGON. IAGON.
IAGON, okay. So, tell us, Elad, what exactly are you guys planning on doing with IAGON?
Well, perhaps as a small intro to the vision of IAGON or how we started IAGON, my partners and me, so my partners are Dr. Navjit Dilhawal and Dr. Claudio Lima. And we actually started from thinking about how to secure medical records on the blockchain. As you know, medical data is very sensitive. And then I came up actually with the idea that we can use the architecture in order to utilize it to secure data for any type of sensitive information, such as banking information, financial information, insurance, and any type of data, even private information like celebrity photographs. They were hacked in the past, as you know. Yeah. So by coupling together the blockchain into the needs of the cloud, we can actually solve one of the problems of providing full security for either personal or business data, whether you are a small and medium enterprise, a private person, or even a corporate. And this is one aspect of IAGON. The other one is that we don't have only the growing demand for big data storage or big data repositories, but we also have a growing demand for processing power to support artificial intelligence tasks and also more conventional tasks like processing these huge databases. And then we thought about a second grid in which we can couple what we call miners or users that provide either the storage or the processing power of their computer or both of them that can be utilized fully securely and anonymously by the grid, by the IAGON, and serve variety of companies that need this kind of power, of course by rewarding the users or data centers that contribute to the grid their own resources.
Okay, so it's a number of different things that you guys essentially are trying to do. And correct me if I'm wrong, like I didn't understand any of that, but it's that you are, I'm going backwards with this, creating miners in a sense so that you guys are allowing for people to do something. It kind of reminds me of something that I've heard about before called folding at home, which is done by Stanford, and a few others that kind of went along that same kind of idea where people use the computer, like excess computer power, or people leave their laptops or computers on or whatever, and it uses that to perform computational processes across a network of computers. So
indeed,
it's kind of like that with that one element of it, right?
Right.
Okay. And then it's allowing people to actually jump onto that using that computational power to then create or process any information that they actually want to do. So say instead of it just being Stanford being the one that's controlling what type of stuff is happening, it's say a garage scientist who wants to find out some information about something he wants information on. He goes to IAGON, says he wants some computational power. It uses the miners' computers, and then that works it out much like a supercomputer or something like that.
Exactly. So basically we unite data centers, owners of servers, and owners also of personal computers and other devices into a sort of a grid, a supercomputer, as you indeed mentioned, for two purposes. One is to provide the processing power, as you correctly mentioned, and the other one is to provide the storage space. So if you have on your disk extra 3 gigabytes that you would like to make some money out of them by renting them out, that's of course possible without, of course, risking the information on the rest of your disk.
Okay. So how do you guys go about making sure that nothing happens to that data then?
Well, basically, we are using the Torrent technology, and we also distinguish your machine from the processing by creating a virtual machine on that, and that will enable to distinguish completely the data. Additionally, our technology is based on the following process. We first take the file that the user decides to upload, we encrypt it with a military-grade encryption, so we completely modify the structure of the data and the content because it's encrypted, and then we shard it to file fragments, to many small file fragments, and it becomes a data file, a DAT file, and therefore, if there is any virus or any risk of malicious software within that file that the user uploads and try to distribute, it's going to disappear. So basically, no virus is going to survive these kind of operations.
Okay, so how does it know, for example, the information has been sharded, as you said, disseminated and whatnot across the computer? What if someone was to find those shards and use a similar type of encryption and then try to upload it?
Okay, here is the beautiful thing. So think about the files as puzzle games. Okay, so you enter a puzzle shop and you see on the shelves millions of games, like the files, thousands of games. So the complete puzzle is in fact the complete file. What we do, first of all, we mask the file by encryption. So literally, we paint the puzzle in black. Okay, that's our operation, the first one. And then we take all the million puzzles and we mix in a huge mixer all the fragments of them, all the shards of them, and we distribute them to millions of miners without any knowledge about their identity, about their reference to the original file, about their attributes, or about the user that uploaded them. The only place where this information is being stored, and by the way, of course, they get some random index number, so it's completely impossible to find out what is the piece and what is the relevance to any file. The only place which holds the address book, so to say, so which fragment was sent to which user, is on the blockchain. So only the person that uploads the file is being able to associate the shard of the file with the original file. And moreover, we also checked in experiments, and it's completely impossible to find out the piece of information when you try to decipher the fragment, because it's highly encrypted, and every file, actually uses different encryption key, and therefore you have to break again and again and again all the pieces and then try to associate it with the original file, with the original puzzle. So I hope my analogy was clear.
Yes, I think that was sufficiently clear.
Thank you.
So I think you guys are doing a pretty good thing with this, because I think there's only, of course there was the similar thing by Stanford, but again, that's locked to Stanford. I don't think there's too many other persons doing something similar with you guys are doing with the blockchain technology and supercomputers. Well, a networked supercomputer in a sense. But what gave you guys the idea to really even start this? Like, what made you decide to actually put all these different pieces together?
Well, I think that we complete one each other in terms of the knowledge and the experience. Together, the three of us have, I think, more than 60 years combined of experience in information technology or in medical record management. So that was a great driver, I think. The fact that, for instance, I was doing variety of projects for banks, financial companies, startups, one of the airline companies, and so on and so forth. Of course, for European policymakers, the European Commission, and others. So it gave me a broad perspective, as well as for my partners, about the needs of companies and individuals. We really, really have to protect the data. You know, I just before this interview, I Googled data leak to see what is new. So apparently 2 days ago, it was found by Equifax, the American lender, that in total to leaking previously, a few months ago, 170 million records of clients, American clients, they found out that another leak of 2.4 million records of clients. That happened 2 days ago. Yeah. And we found out also a variety of other types of links. So all the time you see that companies again and again and again have these problems, that their data is not fully secure. Now, we are aware that you cannot fully secure a system, but our invention, I think, is the fact that in conventional data lakes, once somebody is jumping over the fence around the lake, you know, around the data lake, finds a breach into the system, he or she can swim in the data lake and collect any type of data or document. Our technology actually is a technology of a secure lake. So even if somebody penetrates into the information systems, he or she cannot get access to the data itself. It's protected over the blockchain. And that's the beauty of the blockchain technology. Now, unless the owner of the data reveals the private keys, of course, no one, at least what I heard in the academic discussion, no one in the next 20 or 30 years is able to crack the chain. Okay, and that's also the power of Bitcoin and the other coins. The fact that they are fully protected in the very same way.
Well, what would you say to situations where funds have been stolen from people's wallets? And places like, I think it was Japan that happened recently, where they stole a few million dollars, about a few million ICO worth of, well, a few $1 million worth of ICO from one of the trading companies.
Yeah, I don't know the exact facts how it happened, but as far as I know, it was a matter of the security of the system surrounding the wallet. So perhaps the passwords were kept on the server or not encrypted or any other type of a problem. It's not that someone broke into the blockchain. Otherwise, if someone could have done it, we would see more cases of people just minting for nothing Bitcoins and selling them in the market and devaluing the price of Bitcoin as a result. So I think it was a different reason, considering the security of the private keys, as far as I know.
So it's not so much the blockchain itself, it's more so an issue with the wallet system that it was being held in.
Yeah, perhaps I should update that there is a debate in the academia whether blockchain can ever be hacked or not. Okay, whether the technology can be broken or not. And some advocates of the theory that it can be broken, it can be breached, say that only when quantum computers will be introduced, the blockchain can be hacked. And the forecasts predict actually that quantum computers will become more than a theoretical concept within the next 20 to 30 years. Okay, so probably we are secure until then. Other people in the academia actually argue that blockchain is unbreakable. So even with quantum computing, it cannot be breached.
Okay. I think that'll put rest some people's minds when it comes to that kind of stuff. But
yeah,
I see on your one thing I see on your website is smart contracts, and I think this is kind of where the element of the person who wants to run the test and the persons who are actually using their computers and whatnot to perform the test, there's some smart contract between them. Is that correct?
Yes, we wanted to create a generic platform, not necessarily only for the storage and processing, but also for the smart contract support. And perhaps I should say that to me, it's the less of the innovative aspect of the platform. I would say that the innovative part is the support by artificial intelligence. So in order to operate all the smart contracts, what we are building is a protocol, which we call it Alexandria protocol after the famous library. And it's based on artificial intelligence. It aims at optimizing the grid at any time. So what it does, it collects data about the performance of the grid and tries to find out who are the optimal miners for storing that type or that size of file, or to perform that kind of processing task. So we have a sort of a decentralized artificial intelligence brain for allocating the task and the file fragments to the different miners.
Okay, so does it place into effect, say it's someone who games or whatever, and they get rid of a game, add a game, does it kind of learn that person's behavior on their computer so it knows, okay, don't upload something that's going to put them like into the red in their storage space, because he's probably going to put like another game on here next week?
Yeah, basically, sorry. If it learns, for instance, that my computer is on for 1 hour a day between 2 o'clock and 3 o'clock, then it can allocate particular type of files or tasks, or decide not to at all, to that computer. For instance, files that need archiving, or files with very, very old creation date. And I think that's the real potential here. The fact that you don't randomly allocate tasks and files to miners, but you actually reward them for their performance. And by learning this behavior, you are able to optimize the grid and later on also to predict the performance of every miner.
Okay. So that kind of leads me to two different questions. One is, when you are, and this one's a little controversial right now, for those that are mining,
yes,
that would be using their GPU or CPU, or both?
Both of them, yeah. Both of them if they determine so. So if they decide that they want to be rewarded for either the storage, the CPU, or the GPU, they can mention that as a default in the miner's application. Excuse me.
It's fine. So what's your thoughts on what blockchain and things like Bitcoin and Ethereum and stuff like that, as to what they're currently doing to the GPU market, if you're okay with answering that question?
Yes, definitely. I think that basically we're fostering innovation here. Some of the innovation is going for value creation for the sake of value of monetary standard. Okay, for example, supporting the Bitcoin network, blockchain, or supporting the Ethereum blockchain, which is a standard of money. It's a monetary standard. And I think that was the first generation of the innovation here. What we see here in IAGON is actually referring to the second generation, is the utility tokens. So those are tokens that serve more advanced purpose rather than creating a standard or securing the standard of money, as in the case of blockchain of Ethereum and Bitcoin. For instance, what we do is actually providing cloud services on the basis of that platform. And I think this is a positive advancement in a way that we will find more and more types of innovation. It can serve the medical domains, it can serve financial, it can serve weather forecasting. You know that from what I checked in the industry, startup companies that develop artificial intelligence for different purposes. For example, a photo analysis or a voice recognition or any type of other application, they can pay up to $1 million per month for processing power to services such as Amazon Web Services or Google Cloud, which is a very high amount for a startup company that bootstraps, for example. Sometimes it's not accessible. We aspire to significantly reduce this type of costs. Okay. So I find it as a positive innovation in a way.
So are you saying in a sense that even though because of people using the GPUs and the prices of GPUs going up because people are using buying up the GPUs to do the mining and collecting up of bitcoins and blockchain technologies and stuff like that, it's kind of being offset with this technology at least, and as to what you're doing with the technology?
Exactly. The innovation is positive. When you actually calculate the short term with the long term influences, I think it's a positive influence, a very positive influence in the long run. And beyond that, being involved in the artificial intelligence community for the last 3-4 years, I would say that in any case, the prices of GPUs would have gone up due to the advances in AI. So it just added to that.
I gotcha. So one thing that kind of got me when I was first learning about IAGON is that you guys are actually dealing not just with blockchain, but you guys also seem to be dealing with Tango as well. How does that seem to work?
Yeah, well, what we wanted to create is a platform that can serve multiple standards. And currently, the most trusted and the standard that gained the most experience is actually the Ethereum. We do think that a Tango IOTA is a promising standard by all means. And we deal with supporting a high amount of data, such as for IoT applications. That what creates, according to what I read in research literature, about 70% of the data worldwide, only from IoT devices. So there is a place to support the Tango, only that the technology is not that mature. It didn't gain the experience of Ethereum, and therefore we decided on multiple phases of development where we support, first of all, the trusted, the standard that gain most of the acknowledgement and the experience, that is the Ethereum. We will also learn via that kind of development. We will gain also recognition by the community, and then we can leapfrog into the Tango that supposedly will become more and more mature over time.
I think that's great.
Thank you.
There's one I just remembered the question that I had from earlier as well.
Sure.
In terms of storage, will there be any means to, say, prevent illegal information from being stored on people's computers, and how exactly do you guys plan on working with that? Say, anything from terrorist information to something as like child pornography or anything like that?
Well, that's a good question. What we try to do is to provide a technology that creates added value. And in this respect, what the users are actually storing is their legal obligation. Okay, so if I choose to store, for instance, my bank records, and that's legally correct, okay, I do a trustful use and there is no problem. But if there is some kind of an issue for terrorist information, for instance, I think that it will be harder to break into that. Of course, there will be a need to obtain the private keys. But this is the strength of the technology. I mean, we create this technology in order to prevent any type of malicious or negative use of data, which happens again and again and again. And it's like the internet or the mobile, right? Like 99.9% of us use it for legitimate purposes. And it really added to the quality of our life and also to the sense of security, communication, and social ties. And here it's the same. I think that the vast majority of users are going to use it for legitimate purposes, so why prevent them? On the top of that, I guess that law enforcement agencies have their own methods in order to find out the private keys when needed.
Okay, I think I fully understand what you're getting at with that. So again, IAGON is secure storage. It is a means for people to get connected to a potentially worldwide supercomputer, and
Yes.
a means for people to donate their storage space, their CPU and their GPU processing power, to then assist with that worldwide supercomputer and get a payout from that for their contribution.
That's right. And on the top of that, it's also a learning platform. So it actually operates decentralized artificial intelligence protocol in order to continuously learn and optimize the grid for the benefit of all users.
Okay. Well, Elad, thank you for coming on to today's show. This has been a learning experience for me, and I'm sure for my guests. Well, my listeners. And again, thank you for coming on.
Thank you for having me on your show, and of course, you are welcome to visit our website, www.iagon.com, IAGON as IAGON. Thank you very much, Michael.
Not a problem. And everyone,
it was a pleasure.
It's been a pleasure as well, Elad. Everyone,
thank you.
Have a great day.
Thank you. Bye-bye.